Okay, here we go. We're starting linear algebra 4. This part of the linear algebra is about matrices. So the first question I have, do I choose the red pen or the blue pen? Okay, there's my matrix jokes. Can't stand them. Okay, here we go. Element notation. So if I have a matrix, okay, matrix is made of, you can see it on here, we have matrix A. Matrix is a group of numbers arranged in an array. An element A sub I sub j, Aij, is in the ith row and the jth column. So rows go across, columns go up and down. So rows go back and forth, columns go up and down. Think about columns in front of your house. Okay, the order of a matrix. Oop, that didn't go well. Let's do that. The order of a matrix, okay, is determined by how many rows and columns. A matrix of order mn has m rows and n columns. I call it an m by n matrix. So what is the element of A32 of matrix A? That's not A32, that's A32. So what I do is I go to the third row, so ith row, so I go to the third row. Rows are across, 1, 2, 3, third row is here, and I go to the second column, which is here. So that would mean it's 81. So A32, that element is 81. And what is the order of matrix A? Well, I have 1, 2, 3 rows and 1, 2, 3, 4 columns. So that's a 3 by 4 matrix. And the order of the matrix is important when you're adding and subtracting matrices. Okay, matrix addition and subtraction. Speaking of which, combine corresponding elements. So if I'm adding two matrices, then I add up the corresponding elements. The one that's in A11 in one matrix, that's added to A11 in the other matrix. And matrix scalar multiplication means you multiply the elements by a scalar. In other words, the number in front. You can only add matrices that are the same size, because they are not the same size. They do not have corresponding elements. They absolutely need to have corresponding elements. So I want to perform these operations on this one here. So I have matrix, the first matrix plus 3 times the second matrix. So if I do this, what I need to do is I take the first matrix, 5, 2, 1, 7, and I want to add that to 3 times the second one. So I multiply the second one by 3, which means it's 3 times every object inside. So I have 3, 33, negative 18, and 0. And then I add these two matrices together. I add the corresponding parts. So my new matrix, this is a 2 by 2, this is a 2 by 2. My new one is also going to be a 2 by 2 matrix. Negative 5 plus 3, I get negative 2. 2 plus 33, I get 35. 1 plus negative 18, I get negative 17. And 7 plus 0 gives me 7. I'm going to pause. And here we go again. So on the second one, what I need to do is I have a 3 by 2 and a 3 by 2, so I can add them together. 2 times the first one minus 4 times the second one. So I multiply the first one times 2. So I get a matrix where I have, I don't know if that's enough room. Let's do this first. It sometimes helps actually to print in the first few numbers. So I get 130, negative 24, 28, and then I have 10, 0, negative 34. And then it's actually easier to add than subtract. So what I'm going to do is I'm going to multiply all of these by negative 4. So I'm actually going to add the second matrix. And so I get negative 48, negative 36, 12, negative 16, negative 168, and negative 52. And then I want to add these two together to get my answer. So I just add the corresponding parts. 130 plus negative 48 gives me 82. Negative 24 plus negative 36 is negative 60. 28 plus 12 is 40. And then negative 16 plus 10 is negative 6. 0 plus negative 168 is negative 168. Negative 34 plus negative 52 is not negative 52 that I have down here in my notes. That's negative 86. Okay. Easy peasy, right? Same thing here. So I have, this is how we label matrices. We use capital letters for matrices. We use lowercase letters for the elements within a matrix. So if I want negative 6b, all I'm doing is taking negative 6 times b. Negative 6 times every part of b. So negative 6b would be, that would give me 6. And negative 48. And 12. And 30. And then the next one, if I want to do 3a plus 2b, I do 3 times a, which would give me negative 12, and 9, and 3, and 0. I love zeros. Plus 2 times b, negative 2, 16, negative 4, negative 10. And then I just add those together to get my answer. Negative 12 plus negative 2 is negative 14. 9 plus 16 is 25. 3 minus 4, negative 1, and 0 plus anything is that anything, so I have negative 10. See? Piece of cake, walk in the park, easy peasy, right? Okay. Now we get to matrix multiplication. This is not as easy. This is not like addition and subtraction. It completely changes everything. To obtain the elements Aij in the new one, you multiply the ith row of the first matrix by the jth column of the second matrix and add them together. Okay? And it is very important what the size is. In order to be able to multiply two matrices, they do not need to be the same size. However, the columns in the first matrix have to equal the rows of the second matrix. And I need to pause. Okay, so yeah, I'm recording again. So the rows of the first has to equal the columns of the first need to equal the rows of the second. And my answer is the rows of the first and the columns of the second. Okay, so I will not get the same size unless they begin at the exact same size. I will not get the same size. They don't need to be the same size to multiply them. Okay, now when you're multiplying two matrices, here's what you do. You multiply the rows of the first one times the columns of the second one. So I take the elements in here times the elements in here and add them together to get my space. So that's the first one here. I take A and B times E and G. So I have AE plus BG to get that first element. And then I do, to get the next one down here, to get the second column, first row, I take the second row, first column. I do CD times EG, so I get CE plus DG. That's how I get that one there. And then I do the same thing for the second column here. AB times FH. So I have AF plus BH. And then for this bottom one I have down here, I have CG plus DH. And that's how you get your elements of your matrix when you multiply them. So in order to get AB, I need to take these rows times these columns. So A times B, 2 times 0 plus 3 times 5 gives me 15. I will do, and then I do for this next one down here, 4 times 7 times 0 times 5. 4 times 0 is 0, 7 times 5 is 35. And then I do the same thing for this back column here. 2 times 3 times 1 times 6. 2 times 3 is 2. 3 times 6 is 18. 2 plus 18 is 20. And then 4 times 7, 4 and 7 times 1 and 6, I get 4. 7 times 6 is 42, plus 4 gives me 46. So when I do A times B, this is what I get. Now, when I do B times A, I do the same thing in reverse. Okay? I'm going to take these rows times these columns. So I go 0 and 1 times 2 and 4. So I end up with, in this first one here, I get 4. I do 0 and 1. Yeah, I do 5 and 6 times 2 and 4. 5 times 2 is 10. 6 times 4 is 24. So I get 34. And then I do 0, 1 times 3, 7. So I get 7 here. And I do 5, 6 times 3, 7. So that's 15 plus 42, which gives me 57. Notice that with multiplication of matrices, A times B does not equal B times A almost every single time. It is not the same as regular multiplication. It does not come up the same thing every single time. So you got to be careful about that. So let's do a couple more. So I have A, B, and B, C, and I have A and B. Now, the order of A, B, this is a 1 row, 3 columns. This one has 3 rows and 1 column. So I can multiply A times B because these two numbers here are the same. And my answer is going to be a 1 by 1 matrix. I take this row times this column and add the elements. Okay? So I have -1 times 7, -4 times 2, and 3 times -6, and I add them all together, and I get -33. This is a 1 by 1 matrix. It's got 1 element. Now, if I do B times A, B is 3 by 1, A is a 1 by 3. I can multiply them because these are the same, and when I do multiply them, I'm going to get a 3 by 3 matrix. Okay, so when I do that, I'm going to take these rows times these columns. Okay, so I'm going to just multiply one thing to get every single one of these numbers. So I have 7 times 1 gives me -7. 7 times -4, -28. Sorry, wrong spot. To get this first row, second column, I do 2 times -4, sorry, -8. And then I do -6 times 3. Sorry, times -1. Oh, I'm screwing this one all up. So I do this row times that first column. That's right. Do all of these times -1, -2, and 6. Then for this next row, I do all of these times -4, -28, -8, and +24. And then I do all of these times this one here times 3. So I get 21, 6, and -18. Any questions? No? Good. Okay, let's move on. So this one here, I have a 3 by 2, and this is a 2 by 4. 2 by 4, so I can multiply them because these are the same, and my answer is going to be a 4 by 4 matrix. So I do these times these. Sorry, 3 by 2, 3 by 3, 3 by 4, not by 4, 3 and 4. Oh my God, I got to slow down a little bit. So 4 times 1 plus 2 times 0. That gives me 4 in my first spot here. And then I'm going to do this one times this one here. So I do 1 and 3 times 1 and 0, I get 1. And then I do this one here, negative 1 and 7 times 1 and 0 gives me negative 1. There we go. Now I need to do the second one. So I do the first column, second row. First column, second row. 4 and 2 times 2 and 2. So that's 8 and 4 gives me 12. And then I do 1 and 3 times 2 and 2. That gives me 2 plus 6, which is 8. And then I do negative 1 and 7 times 2 and 2. Negative 2 plus 14 gives me 12. And then I do, to get this row, I do these 3 times that row to get the next one. 4 and 2 times 3 and negative 1, that's 12 minus 2, which is 10. 1 and 3 times negative 3 and 1, that actually ends up giving me 0. And negative 1 and 7 times 3 and negative 1, that gives me negative 10 again. And then I do the same thing times this last row to get this last one. 4 and 2 times 4 and 6, 16 plus 12 gives me 28. And then 1 and 3 times 4 and 6, so 4 plus 18 gives me 22. And then negative 1 and 7 times 4 and 6, that's negative 4 plus 42, that gives me 38. And on this last example here, I have a 2 by 4 and a 3 by 2. These are not the same. It is not possible. And okay, here we go to the last page of the notes. So what we can do is we can give, one of the things matrices are useful for is assigning values to different things and putting them in quantifiable numbers rather than something else. So if I look at this particular quadrilateral Q, I can make a matrix out of its coordinates, where the x coordinates are the top row. These are my x's, and these are the y's, and those are corresponding points. I have negative 2, 3 is this point down here, negative 2, 3, negative 3, corresponding points. What are the coordinates of the quad shifted 4 right and 1 down? So what you do is you take the matrix you have, negative 2, negative 3, negative 1, 2, 3, 4, 1, negative 2. And if I'm shifting, I'm adding and or subtracting to them. 4 to the right means I take my x coordinates and I add 4 to all of them. So I add 4 to every x coordinate. And then 1 down means I add negative 1 to every y coordinate. I move every y coordinate down 1. And that will give me the new quadrilateral 2, negative 4, 3, 1, 7, 5, sorry, 7, 3, and then 5, negative 3. So this is a thing of, if I assign values to something, I can move them up and down. I can do other things to them. Where might this come in handy? Think about video games, animation, computer things. If you can quantify it, you can do things with them with a computer, because the computer works with numbers better than anything else. Okay, if I want to shrink the quad to half its perimeter, I want to do 1/2 of everything. Okay, so I do 1/2 times negative 2, negative 3, negative 1, 2, 3, 4, 1, negative 2. If I want to make it half as big, I multiply every point times 1/2, every coordinate times 1/2. I bring it in. So I multiply that out, and I'm getting negative 1, negative 3/2, negative 1/2, 1, 3/2, 2, 1/2, and negative 1. And then the last one. Let B equal a particular matrix. Let it equal 1, 0, 0, 1. Find B times Q. So I take B, negative 1, 0, 0, 1, and I multiply that times Q, which negative 2, negative 3, negative 1, 2, 3, 4, 1, negative 2. And if I multiply that all out, remember it's these rows times these columns. So if I want to get the first spot, if I want to get 1, 1, I do row 1, column 1. So negative 1 times that. So when I do row 1, when I do negative 1, 0 times each one of these, what's going to happen? It's going to change the sign of all the x's, or all the top, and 0 times all the bottom. So when I add them together, 0 times everything on the bottom plus the opposite of everything on the top, it basically just takes that top row and makes them all different signs, change the sign. So I get 2, 1, negative 3, 1. And when I take this bottom row times every column, that's 0 times all the tops and 1 times all the bottoms, so the bottom just repeats itself. Negative 3, 2, 4, negative 2. Okay. And if you plot these points, if you take and plot these points on the grid that we already have existing, 2, negative 3, so I go, instead of negative 2, negative 3, I go 2, negative 3, I go to here. And then I go negative 1, 2, negative 1, 2. Wait, sorry. Sorry, my new one, sorry. 1, 2, 1, 2. I end up going up to here. So I go from here to here. And then I go negative 3, 4, negative 3, 4 takes me up to that. And then I go to negative 1, negative 2, negative 1, negative 2 to here. And what did it do? It took it and it flipped it across the y-axis. Thus endeth the lesson.